Welcome to SC25 here in St. Louis, Missouri. This is the supercomputing conference to end all supercomputing conferences, talking all things HPC. And we're going to get into a very cool subject with Delta Electronics, specifically talking about their cooling solutions that go from the chip level all the way through the system and data center level. And I have two very interesting guests to talk about that. Dr. Tan, welcome. And Jeff Chang, welcome.
Pleasure is ours.
I just want to jump right in. Delta Electronics has what it refers to as a chip to system approach, sort of a starting at the microprocessor level, going through amazing systems like the CDU behind us. What were the customer challenges and market trends that you've seen that led you to go in that direction?
So the chip-to-system comes higher computing density and higher thermal loss, driven by AI and HPC workload. Traditional cooling is reaching the limit as like the chip power over 1,000 watts and the rack density over 100 kilowatt. Customers now require scalable, energy efficient, and easy deployable cooling systems that work across from grid to system. So Delta offers integrated cooling system from chip, board, rack, and system level. This end-to-end design maximizes performance and energy efficiency, while enabling modular scalability and simpler deployment. By unifying cooling at all layers, Delta supports the sustainable long-term growth of a global AI infrastructure.
I'm interested in your microchannel lid and integrated heat spreader technologies, and I'm curious about how your history with your sort of core competence in sustainable energy solutions has fostered that. What can you tell me about that?
So Delta microchannel lid and integrated heat spreader technology are engineered to deliver superior thermal performance at the chip interface. And this solution leverages Delta precision thermal engineering expertise to reduce the thermal resistance and improve heat transfer efficiency.
Yeah, and this technology leading by next group of engineers will allow people to go in higher computing with the energy needing, also reducing the energy footprint moving forward for next generation upcoming AI servers.
And when we call it a microchannel lid, it's the form factor is like a lid on the microprocessor itself.
Yes. I think traditionally we do the cold plate on top of the lid. So Delta is starting on using the lid to target the heat source from where it comes from, right? So to better spread the heat source before the cold plate get to target on do the cooling job on the chip.
And that's something that would be designed in and would sort of enter the supply chain at an earlier point.
Exactly.
Yeah.
At the chip designer level.
Got it. Very interesting. Well, so when we look at AI data centers, right now we're absolutely pushing the limits of density and power to an AI rack. What are the advantages of your liquid to air hybrid systems in terms of balanced performance?
AI data center now operate at the high power density that require integrated approach rather than a single cooling method. So Delta's portfolio span board level, subsystem, and system level cooling, enabled flexibility deployment in both new build and retro environments. And the liquid cooling solution, including corporate for next generation AI chip, In-Rack CDU, and rack manifold for high capacity heat remove. Air cooling solution range from high efficient server fans to advanced HVDC fans designed for room and facility level cooling. So Delta Total Thermal Solution provides seamless integration for next generation infrastructure.
So there isn't one size. This is not a one size fits all world
No.
at this point.
No.
And air cooling is still relevant today.
Yes. However, it is a one-stop shop, a Delta cooling solution. As we started from cooling our own power supply, now we move into what Nick is mentioned, the liquid cooling side, right? So we're going to be focused on efficiency, right? Let's talk about, you say 1 watt at cooling level. So that translates into exponentially energy saving at a facility level. Like for example, let's say if you are a farmer, you're farming apple, right? With years of experience and expertise, you can actually produce 1 extra apple per tree, and per se you have 1,000 trees. They give you 1,000 extra apple, right? 1 watt, 1,000 watts. Now you have megawatts.
Yeah.
1 million apples, something like that.
Yeah, I love the orchard analogy. Let's stick with that for a moment.
Okay.
Because imagine we're looking at this and this is 1 apple tree. When you look at a hyperscaler like Google, who has arguably very, very, very large orchards of servers and things that need to be cooled, what are you doing to collaborate with hyperscalers like a Google?
So Delta contribute to industrial-wide innovation in open and scalable cooling systems for hyperscale AI environment. Solutions such as 2 megawatts in-rack project diffuse open CDU highlight the market shift toward large capacity module and serviceability. Liquid cooling design through close engagement with a hyperscale such as the Google. Delta aligns engineering roadmap with customer operation need and real-world data center challenges. By supporting open architecture and energy efficient design principle, Delta helps accelerate the industrial transition towards scalable cooling ecosystem built for AI growth.
So something like this model that we see behind us would be designed into, say, hyperscalers often refer to a pod of infrastructure. This would be 2 megawatts worth of cooling. And as those monster data centers are built out, you would think of 2 megawatts, 2 megawatts, 2 megawatts, and it would be part of the design.
Yes. As Google's TPU design, I think their perspective is to start with they want to put all the TPU together, denser and denser, right? Then as they progress in that route, you need more cooling, right? So we're starting changing from in-rack into the in-row scale, and then multiple in-row scale moving forward, working with Google.
As you look ahead and you think about your integrated thermal solutions, how is this going to shape sort of the evolution of next generation AI and high performance computing in general? If we think about power coming in, heat needing to be dissipated, first of all, we have to figure out how to generate the power. But so how will you be shaping that evolution moving forward?
Delta's integrated thermal solutions are positioned to drive the global evolution of AI and HPC by bridging sustainable, scalable, and high performance. We bridge chip level, rack level, facility level cooling to optimize thermal performance across the entire computing ecosystem. And the long-term vision is to enable carbon smart data center where intelligent power and thermal systems work together to minimize energy waste and support overall grid standard. This innovation support the industrial's broader movement toward net zero goals while unlocking higher compute density and performance for future generation of AI and HPC systems.
It makes a lot of sense. And when you look at the significant constraint that the availability of power represents, one way to attack that is, just generate more power.
Yep.
We're not sure exactly how the world is going to do that yet. But along the way, making sure we use that power as efficiently as possible by doing exactly what you're doing, starting out at that microgrid lid level, all the way through every step, liquid air hybrid, all the way through what is now a 2 megawatt standard, you're attacking that from an efficiency perspective, one step at a time. I'm curious, do you see in the future more standardization across, or do you think that your chip through system design is going to be something that will be needed forever?
No, like you said, right?
It's a bit of
yeah, it's
speculation.
Yeah, but like you said, right? I think people are driving into like a standard, like OCP, like NVIDIA is driving to everybody to be a standard, right? To make it more efficient for everybody, right? As we know, we are moving into an AI as a backbone of the human being, right? So the efficiency of power, you keep mentioning that, and also the cooling solution, the driving force, right? The pace of progress of our AI moving forward, right? So as Delta, we position ourselves not only as a technology solution provider, but actually a thought leader on the sustainable foundation in this AI era moving forward.
Any final thoughts from either of you?
Yeah, oh, maybe one more last thing. As Nick mentioned, right, the chip level reaching 1,000 watts.
Yeah.
The viewers, by the time you see this, it's probably 2,000 watts.
So great point. While we're all impressed by 1,000 watts, we're pushing towards 2,000 watts. I like to remind people that the average hair dryer might be around 1,500 watts. Imagine 30 or 40 or 50 or 60 of those things in generating heat in a cabinet. We're talking about massive amounts of heat that has to be dissipated.
It's nice and cool. Little square.
Yes, it's nice and cool in here, and we're very comfortable. It's hard until you're standing next to these systems that have to be cooled. It's hard to fully appreciate it, but that's an excellent point. So watch that. By the time you see this, that the era of 2,000 watt GPUs will be upon us. Dr. Tan, Jeff, thanks so much for spending time with us to talk about your cool technology. For 6.5 in the booth, I'm Dave Nicholson. Stay tuned for more exciting coverage of all events related to supercomputing and the HPC industry.